Hello everyone, this is the question 8. Important questions, simple answers video series about deep learning. And the question is one of the first questions you will ask yourself, especially in the beginning of hands-on part. How do you decide the right number of layers and neurons? Okay, let's look at the answer step by step. First of all, there is no one right number for all problem types and all cases, which means there is no one configuration, one architecture, best for all, or one solution for all. Before elaborating the answer, I want to remind a couple of things. Let's look at the architecture of neural network. As you see, we have one input layer, one output layer, and hidden layers. And if you increase the layers, you will increase the depth of the model. And if you increase the number of neurons in the layer, you will increase the width of the model. You should keep in mind that more layers means deeper, more neurons means wider, and the position of the neurons also important. When I say position, I mean the layer position. For example, this neuron in the output layer, this neuron in the hidden layer, and this neuron in the input layer. Okay, after this reminding, let's look at the general rule. If you achieve same performance scores with less layers and neurons, use those architecture. So the important thing is that more layers and more neurons cause more connections and more parameters in the model architecture, and then it will cause computational cost. For the input layer and output layer, we are not so flexible, but for the hidden layers, we are quite flexible to choose number of layers and neurons. And let's look at these two examples. First one, we have 3 nodes. Two of them have 2 layers. In the first one, we have 6 neurons. In the second one, we have 7 neurons. And as you see, we have totally 8 parameters in this. 6 connections plus 2 biases. Here 12 connections plus 3 biases, so 15 parameters. More parameters means more calculations, and this will affect the computational efficiency. And as I said before, this is valid for the hidden layers. For the input layer, we are not so flexible. You will have one input layer in the model, and the number of neurons in that input layer will be decided according to the input dimension. Again, we will have one output layer in the model, and we will decide according to the problem type. If it is a regression problem, if it is a regression model, then we will add one neuron with linear activation function. But if it's a classification problem and a binary classification, again there will be one neuron, but the activation function will be sigmoid or 10H. And if it is multi-class classification, then number of neurons will be equal to number of classes. As you see here, we will decide according to the type of layer and the problem type. And the last one, I want to give a couple of tips. First of all, more layer and neuron can cause overfitting. Be careful about that. So sometimes you need to reduce the numbers. And the second one, not for all cases, but usually wider is better than deeper. So what does it mean? Let's think that you have two different models, two different architecture. Two of them have 4 neurons, but in the first one, there is no any connection between the neurons because this is the rule of architecture, but in the second one, there are some connections because these 2 neurons and these 2 neurons are not in the same layer. So what does it mean? If it is deeper, there will be more connections and more parameters. In each iteration, in the backpropagation, there will be more calculations, which causes computational cost. Also, if it is too deep, then it can cause vanishing gradient problem. Okay, number 3, usually the best idea starting with 1 or 2 layers, then slightly, one by one, adding more layers until reaching acceptable score. And number 4, these are not, let's say, golden standard numbers for the neurons, but usually you can see these common numbers, 512 and 256. So you can start with this, then you can add layers with the half of the previous one. So the architecture will be something like that. And that's all. This is an answer for this question: how do you decide the right number of layers and neurons in the neural network? See you in the next question.